Previously we have learned what is statistics. Now we will see what are different flavors of statistics. Statistics are divided into two types, based on their uses. 1. Descriptive statistics. 2. Inferential statistics. What is descriptive statistics? Before you make any statistical analysis on your system, you need to understand it first. To understand the system, at first you need to collect information about it. So, descriptive statistics help us for summarizing and organizing the data, so they can be easily understood. Descriptive statistics enable us to present the data in a more meaningful way, which allows a simpler interpretation of the data. Each descriptive statistic reduces lots of data into a simpler summary. Descriptive statistics is simply describing the data, without necessarily trying to build any prediction or any models out of it. It is simply telling you the way it is. Running descriptive statistics on your data set is absolutely crucial, before you begin the process of conducting the inferential statistics. So we run descriptive statistics so that we can describe the characteristics of our sample, and infer that to the larger population. Descriptive statistics are very important because, if we simply presented our raw data, it would be hard to visualize what the data was showing, especially if there was a lot of it. Data is typically arranged and displayed in tables, or graphs. We summarize details using histograms, pie charts, bars or scatter plots. For example, grade point average, GPA. This single number can describe the general performance of a student, across a potentially wide range of course experiences. Every time you try to describe a large set of observations, with a single indicator, you run the risk of distorting the original data, or losing important detail. The batting average doesn't tell you whether the batter is hitting home runs or singles. It doesn't tell whether she's been in a slump or on a streak. The GPA doesn't tell you whether the student was in difficult courses or easy ones, or whether they were courses in their major field, or in other disciplines. Even given these limitations, descriptive statistics provide a powerful summary that may enable comparisons across people or other units. Example 1. Suppose we want to describe the test scores in a specific class of 30 students. We record all of the test scores, and calculate the summary statistics, and produce graphs. Average score equals 75.6%. Highest percentage scored equals 96.8%. Lowest percentage scored equals 45.2%. Pass percentage equals 88%. Fail percentage equals 22%. All these values describes the class of 30 students. So, we have used descriptive statistics for describing a system. Example 2. Before buying a specific car, you collect information about that car like top speed of the car in km per hour, power of the car in HP, noise in decibel, fuel economy km/L, 0 to 100 km per hour in seconds. These all information describes the performance of your car. And the values for each parameter that you got are called descriptive statistics. What is inferential statistics? While studying a system, it is too difficult or expensive to collect data from the whole population that you're interested in. So, we collect sample data because it is more cost-effective and less tedious than collecting data from an entire population. The process of inferring insights from sample data is called inferential statistics. With inferential statistics, we try to reach conclusions that extend beyond the sample data. It allows one to come to reasonable assumptions about the larger population based on the sample's characteristics. With inferential statistics, you take data from samples and make generalizations about a population. While descriptive statistics can only summarize a sample's characteristics, inferential statistics use your sample to make reasonable guesses about the larger population. For instance, we use inferential statistics to try to infer from the sample data what the population might think. With inferential statistics, you take that sample data from a small number of people and try to determine if the data can predict whether the drug will work for everyone, that means the population. While descriptive statistics can only summarize a sample's characteristics, inferential statistics use your sample to make reasonable guesses about the larger population. When you have collected data from a sample, you can use inferential statistics to understand the larger population from which the sample is taken. With inferential statistics, it's important to use random and unbiased sampling methods. If your sample isn't representative of your population, then you can't make valid statistical inferences. Example 1. Suppose you are trying to learn about what is the average income of people in India. But it is not possible to collect the salaries of all 1 billion people in India. So, we take samples from each state and union territory. Now, this sample will represent the large population of Indian people. We would consider this sample for our statistical study and can find out the average salary of Indian citizens. Example 2. You have been hired by the National Election Commission to examine how the Indian people feel about the fairness of the voting procedures in India. Whom will you ask? It is not practical to ask every single Indian how he or she feels about the fairness of the voting procedures. Instead, we query a relatively small number of Indians and draw inferences about the entire country from their responses. So, this was all about what is descriptive and inferential statistics. If you have any doubts regarding this topic, please comment down below. I will respond as per my best. Signing out.